Hi, today we're going to talk about iBeacon, which is one of the really the significant change to CoreLocation in iOS 7. So the CoreLocation and core mapping or the map kit changes that have happened in iOS 7 are significantly iBeacons, which use Bluetooth to broadcast additional information about a location and to receive that information. So iBeacon is the receiving side. The broadcasting piece is an actual beacon device. A beacon device can be just a simple little device that is in a specific location that broadcasts the information. It can even be an iOS device or a Mac OS X device that is set up to broadcast this information using the core Bluetooth API. We're going to talk about the receiving part today because that's what's new in CoreLocation. CoreLocation has had region monitoring for a while, but now that region monitoring can interpret and present iBeacon information to the user. There's also a change in the MapKit user interface that we're not going to talk about. This is user-facing only. MapKit now supports a 3D view that allows you to zoom into a particular area in MapKit, showing it as in a 3D representation. So, iBeacon, what is it? Well, we've had geographic region information since iOS 4. Geographic regions were defined and are still defined as being a circle. It's a region defined as being within a certain distance within a fixed point, or from a fixed point. The distance is the radius of the circle. The point is the center. A beacon region is slightly different from that. A beacon region is defined by the device's proximity to a Bluetooth low energy signal. So what's a beacon? A beacon is really just a device that broadcasts a data payload over Bluetooth. So the first step in detecting these beacons within our apps is to determine if monitoring is available. Now there's two pieces to this. There is the hardware piece and the user piece. The hardware piece just determines if we can monitor for region information. The software piece, the user piece, determines whether or not the user has allowed us to monitor these region changes. So we detect the hardware piece by calling the class method, is monitoring available for class, and we pass it a CL beacon region class. This checks the hardware availability, and it'll return a bool. Then we call the authorization status on a CL location manager object, which we have to set up. And this will return a constant, and it'll be one of 4 KCL authorization statuses. They can be not determined, restricted, denied, or authorized. The one we're looking here for is authorized. So if the status is KCL authorization status authorized, then the app will begin receiving beacon notifications as soon as we tell it to. And these notifications are on beacon area entry and beacon area exit. And these are events that are trapped by delegate methods of the CL location manager object. So beacons themselves are identified by a combination of 3 values. There's a proximity ID, which is a universally uniform ID, or universally unique identifier, and it's a 128-bit value, and it identifies the beacon's type or the organization for that beacon. Then there are major and minor values, and both of these are 16-bit values, and these differentiate beacons. So many beacons may have the same proximity UUID, but there could be a differentiator in the major value, and that would differentiate between beacons that have the same proximity ID. And then the minor value differentiates beacons having the same proximity and major value UUID. So these values are kind of hierarchical if you want to think of it that way. For example, Apple gives an example in its documentation of a department store. So the department store might have one proximity ID for all of its various locations, and then a different major value for each specific location within that department store chain, and then a different minor value for each floor in the department store. So by using iBeacon, we can detect not only that we are, let's say, within 200 meters of this department store, but if we're in the department store, we know what branch we're in, and then if we look at the minor ID, we would know, if it were set up this way, what floor of the department store we were in. And then the payload bundle could contain information about what is available, let's say, on that floor. So how do we monitor? Well, first of all, we have to know what proximity UUID we are monitoring for. And if it applies, we need to know the major and minor IDs. And we need that information for any beacon we wish to monitor. So we would instantiate a CoreLocation region object and initialize it with one of these three init methods. Init with proximity UUID and identifier, or we could get the proximity UUID and major and identifier, or we could specify the proximity UUID, the major, and the minor, and the identifier. Now, what's the identifier? The identifier is simply an NS string that you define within the app to refer to that beacon later, or that beacon region later. After you have instantiated this CoreLocation region object, then you would call start monitoring for region and pass that CoreLocation region object. But you call this method on your CoreLocation manager object itself. So now that starts monitoring how do we get the events that we have entered or exited a region. We need to set the delegate for our CoreLocation manager object within the view controller or someplace where we're going to be monitoring these region changes. And then there are two delegate methods that we're interested in. The first is location manager did enter region, and the second is location manager did exit region. And within the bodies of these methods, we will get the location manager itself and the properties thereof, and also the region that we have entered or exited and the properties thereof. And we can do whatever we want to within the scope of the app as appropriate. So for further information on this, and we'll also have a very short demo that shows you some code, but for further information, specifically how to turn the iOS device into a beacon itself, and detecting the proximity or the distance from the device and the actual beacon source, and also how to use some region data within MapKit, see the Location Awareness Programming Guide. Now, this is available on developer.apple.com and also inside Xcode within the documentation window. Thank you very much.